All right, we're looking at a couple theorems today, the squeeze theorem and the intermediate value theorem. First of all, the squeeze theorem, you can try to read this if you want, mainly what it means. If I have two functions, this one in green, this one in blue, and at this point we're going to call it C, their limit is the same. They are approaching the exact same value. And then we have this other function, this pinkish function in F, the function called F. And it's always in between the green and blue functions. It's always between H and G. Well, as these functions get closer to C, they're approaching the same number. And since F is always in between them, there's nowhere for it to go but right to that same spot that the other two are. The limit must be the same now at that point for all three functions as a result, just because this function is literally being squeezed together by those two functions. That's all the squeeze theorem tells you, just that it's being squeezed in, therefore there's only one place it could go. Now, the other theorem, one that we're going to use a lot more often, is called the intermediate value theorem. The key here, we need to have a continuous function on some interval. So when x is going here from a to b is what we're looking at. We're going to look at what the function values are, f of a and f of b. And pretty much what we're going to have is you're going to kind of create this little box area here. And all the intermediate value theorem says is because it's a continuous function, well, obviously then every x value must be hit once and only once in this interval. And since I can't pick up my pen anywhere, I have nowhere to go, I'm going to hit every y value in this box at least once as well. So there's going to be some point somewhere that I can say that my function value equals any number between f of a and f of b. It must exist somewhere, or in this case, actually it'll happen 3 different times. It could be like once up here, twice like right in here, or even 3 times there. Alright, so how we're going to use that, kind of gave you a little sneak peek there, but how we're going to do this is, say we need to find a 0, meaning a place where it's crossing the x-axis. And we want to see, does it exist somewhere in this interval from when x equals 0 to x equals 1? That's what we're looking for. Well, the first step, always, you must see, is it continuous? The function itself. Well, this is a polynomial function. All polynomials always are continuous. So the first thing I need to say is that f of x is continuous. That's step number 1. Now, from there, what I need to do is plug in my function values at these endpoints that we're given, 0 and 1. When I plug in f of 0, I should get -3. When I plug in f of 1, I should get +3. So, just so you can see what we have here, we have that point here at 0, -3, and this point up here at 1, +3. This is a continuous function. It might be a line, well, it's not a line, it's a cubic, but it could kind of connect like that, or it could have kind of maybe gone up and then come back down, or maybe it could have even, gone zigzag about 50 times and then went up. No matter what, one way or the other, these two have to connect, these 2 points, without me picking up my pen. And at some point, there's no doubt I have to cross this line. So the way I'm going to say this is because 0, we want it to be 0, is somewhere between these 2 function values, between f of 0 and between f of 1. Because of that, we know that a 0 must exist on this interval. And that's straight from the intermediate value theorem. So you need to say it's continuous, you need to use the function values, and then show that, in this case we want 0, is in between what those 2 function values are.